Hello friends, in the last lecture we saw how to solve the linear equation using Cramer's rule. So let's see a few more examples on this Cramer's rule. So let's try to solve the equation 4 upon x plus 5 upon y equal to 7, 3 upon x plus 4 upon y equal to 5. So the rule says like we need to find the determinants, but to find the determinants the equation looks complex. So let's simplify it. To simplify, we can replace 1 upon x by a and 1 upon y with b. So after doing that, the equation becomes 4a with 5b equal to 7 and 3a plus 4b equal to 5. And now it's good we can find the determinants. So how do we find it? Just replace the value of a and b. Sorry, this should be a and b. So what are the values of a? It's 4 and 3. So replacing the values with 4 and 3 in the column of a. Now placing the value of b in column b. So values are 5 and 4. So placing those, and now we can find the determinants by cross multiplication. So 16 minus 15 becomes 1. So now find the value of a. So to find the value of a, we'll replace the coefficients in the column of a. So what are the values? They are 4 and 3. So we'll replace with the equations value, which is 7 and 5. So replacing it while we keep this part as same, and finding the determinant by cross multiplication, which becomes 28 minus 25 is 3. Similarly, we'll find with b. We'll keep the coefficients of a same, which is 4 and 3, and we'll just replace these values, which are 7 and 5. So the determinant becomes minus 1. So now let's calculate the value of a. It's calculated as determinant of a with the value of this determinant, which is equal to 3 divided by 1 is 3, and for in case of b, minus 1 upon 1 is minus 1. But what we did is we replaced 1 upon x with a and 1 upon y with b. So putting the values back, so 1 upon x becomes 3. So x is equal to 1 upon 3. And y, 1 upon y is minus 1. Therefore 1 upon y equal to minus 1 is, so what I'll do is I'll multiply this here. So 1 equal to minus y. So y equal to minus 1. And as I told you, like you can put in any equation the value of x and y and check if LH is equal to RHS. Let's see one more example. So this is 4 upon x minus y plus 1 upon x plus y equal to 3 and 2 upon x minus y minus 3 upon x plus y equal to 5. The similar way we'll replace this 1 upon x minus y with a and 1 upon x plus y with b to simplify the equations. So these are the equations after replacing. So the first step is to find the determinants. So the value of determinants is found by placing the values. What are the value of this a is 4 and 2. So putting the value 4 and 2. And the value of b is 1 and minus 3. So putting the value here. So we get it as minus 14. So in case of a, we'll replace the values with 3 and 5. And we'll keep this part as same. So after solving we get the value as minus 14, and in case of b we'll keep this part as same, that is 4 and 2, and we'll change these values with 3 and 5. So the value we get is 14, and we calculate dA, which is minus 14 upon with this value which is minus 14, we get it as 1. And in case of b, what is the value? 14 divided by minus 14. So we get it as minus 1. But Here we got the value of a and b, but we need to actually find the values of x and y. So what we did was 1 upon x minus y, which is equal to a, and the value of a is 1. So 1 upon x minus y equal to 1, and 1 upon x plus y is equal to b, which is minus 1. So what I did is I multiplied here. So 1 equal to 1 into x minus y. So x minus y equal to 1. And similarly x plus y equal to minus 1. So what we can do is we can just repeat the process again, because these are again two more equations. So we'll find the value of determinant, which comes out to be 2. Similarly, we'll find the value of d of x and d of y. We get it as 0 and minus 2. So the value of x will be equal to d of x, which is 0 divided by 2. So which ultimately comes as 0. And for the value of y, which is minus 2 divided by 2, which is equal to minus 1. So here we get the value of x and y as 0 and minus 1. So if you put it any of the equation like 3 or 4, you'll find LHS equal to RHS, and that shows that whatever solution you found is correct.